resource persons from various industries and also to guide the chemistry students about the skill development for the industry. Let us move on to this industrial session. For that, we have Dr. S. Sugunan, an eminent researcher and retired professor of Department of Applied Chemistry, CUSAT, and his research areas includes catalysis, reaction dynamics, statistical mechanics, spectroscopy, and super resolution microscopy. Over to you, sir.
Good morning, everybody. Today we have the first speaker, Shri N. Chandrasekhar. He is the Chief General Manager, BPCL, Mumbai Refinery. He is a BTech from Chemical Engineering, BTech in Chemical Engineering from Coimbatore Institute of Technology, and he has an MBA from ICFA FAI University. His career starts from Bharat Petroleum Corporation Cochin Refinery as a Chief Manager, Head Bharat Government Refineries Limited, Bina, Madhya Pradesh, and General Manager, BPCL, Mumbai Refinery. He will be talking on chemical industry challenges and opportunities. Kindly talk for about 25 minutes and give 5 minutes discussion. Thank you.
Good morning to the chairman of this session, Dr. Sugunan, and good morning to my co-panelists and co-speakers, and good morning to the faculty at CUSAT, and good morning to all the participants in the virtual media. Thank you very much for the chairman for giving me a good introduction. I am speaking from the Mumbai Refinery of BPCL. From Mumbai. Before I start today's talk, I would like to remind all of you to practice SMS, that is social distancing, mask and sanitizer, because this is the need of the hour now. And to face this pandemic that is gripping us in various forms, this is the only way and the right way. So I request all of you to please practice SMS in your daily life. Now I will come straight to the topic, chemical industry challenges and opportunities. And quickly I will go to the slides. As the chairman has said, I'll be taking about 20-22 minutes, and I will be opening the questions session for questions and answers. And we will be completing the session in half an hour's time starting now. First, I would like to give you a small overview about the oil industry in India. We have three stages of the entire gamut operating in India. One is the upstream sector, downstream sector, and the gas and transport and distribution sector. The upstream structure, as you see, this is dominated by the agencies who are involved in oil exploration, and the middle part, that is downstream, refining, marketing and pipelines. This is what we are from. We have the biggest company in India, Indian Oil Corporation, followed by Bharat Petroleum, that is my company, and Hindustan Petroleum, Mangalore Refineries, Reliance and Nayara in the private sector. And you are all aware that BPCL Kochi Refinery, operating a 15.5 million refinery just next to CUSAT, is the largest public sector oil refinery in the country today. And the biggest player in India today, as far as the refining business is concerned, is Reliance Industries, having a 60 million refinery at Jamnagar. And for the gas, we have Petronet, GAIL, IOC, and the other private players in the market. Coming to Bharat Petroleum, we are a Maharatna company. We are the second largest oil marketing company, and we are ranked in the Fortune Global list. And you name any award, BPCL has got the award. We share about 26% of the market share. BPCL operates 4 refineries in the country today: Kochi Refinery, the Mumbai Refinery, the Bharat Oman Refineries Limited in Bina, Madhya Pradesh, and the Numaligarh Refinery Limited in Assam. And all the 4 refineries of BPCL are compliant with the Bharat 6 stage standards. And the total refinery capacity of the group is about 33 million tons and 33 million metric tons. And we have enough pipelines to take our products from the refineries to reach the end customer. This is a slide which I will not be talking about in detail, but I will be leaving the slide with the participants. So in your free time, you can just go through this slide and you can understand how complex our industry is, and with what all odds that we are fighting to keep this industry running, and how many matrix are there for solving on an each daily basis or even on a second basis. So unless this entire system works in tandem, in parallel, concurrently, the end customer will not be able to get a drop of petrol or a LPG cylinder at his house. So at your leisure, you may please see the slide. And if time permits, at the end, I will take you through this slide also. But let us move forward now. So basically, the previous slide is divided into the following 5 segments. First is the crude oil supply. So where we have a very clear-cut crude oil selection purchasing policy, and we bring crude oil from almost the entire part of the globe. You name any country, we have purchased crude from that country. We have the refineries operating at full capacities to ensure that these crudes are converted into value-added products on a continuous basis. And once the refinery produces the value-added products, they are very, very efficiently and effectively transported to the nook and corner of the country by a huge array of pipelines. We have barges, rail, road distribution system, and across the country, we have got a lot of depots where the products are again stored. The secondary freight consists of trucks and even sometimes bullock carts, hand carts now for transporting this fuel to the farthest corner of our country, including the Indo-China border at Kashmir and the Indo-China border at Assam. Wherever you see vehicles moving, you can be well assured that it is from the effective processing and the logistics of the entire oil companies operating in India. And you are aware that we have got presence in retail, petrol and diesel, LPG, aviation and lubes. Now, I'll spend one minute on this slide. What is the refining process? We have the crude coming into the refinery. And the crude is undergoing the primary processing called crude distillation, where the crude oil, the raw crude oil is distilled into the first cut of products. The first cut of products will be it will be the gas, followed by the liquefied petroleum gas separation. And just below the liquefied petroleum gas, you have the naphtha streams. And from below the naphtha streams, you will have the kerosene streams and the diesel stream and the atmospheric residue. So in the earlier times, the atmospheric residue was directly sold as fuel. But as the technology has improved, we are seeking value-added products from the atmospheric residue also. So we have something called a vacuum distillation, where the atmospheric residue is further distilled in vacuum. You are getting a product called vacuum gas oil. The vacuum gas oil is either catalytically cracked to have further lighter products like LPG, MS, and diesel, or it can be hydroprocessed in a hydrocracker to remove the sulfur to again produce value-added properties, value-added chemicals. So basically, it is the primary processing. Then you have the hydrotreating for diesel, kerosene, vacuum gas oil, and naphtha, and the value-added units. Value-added units are those units whose products directly we can sell in the market. hydrotreating is very, very important now in the context of both the chemist and the chemical engineer. So here I would like to draw the attention of all the listeners here who are basically MSc chemistry or chemistry professionals, that here is a stage where the chemist and the chemical engineer meet for hydrotreating, because the hydrotreating involves treating of the products by using hydrogen and catalyst in the presence of heat. So once this happens, the sulfur in the feed products are converted into hydrogen sulfide, and thereby the products coming out of the hydrotreater are kept at a very low sulfur levels, probably at ppm levels. The hydrogen sulfide generated is absorbed in amine, released again, and converted back to sulfur. So that is how the process takes place. And in my later slides, I will be talking more about this hydrotreating and how we want the help of the chemists here, the chemistry professionals who are more into the research side and analytical side to help the oil industry to achieve the aims and the goals that is set for. This is again a block diagram of the refinery. I told you about the crude unit. At Mumbai Refinery, we have 2 crude units processing low sulfur and high sulfur crude simultaneously. And all the units in yellow color are basically the diesel treaters and the catalytic crackers. And on the right side, you can see the full description of the process units. And I also urge all my listeners here that at the end of the program, I will be sharing my coordinates with the organizing committee. So in case there are further questions on detailed process requirements, I will be only very pleased to answer. So coming to the product profile of the refineries, this is a typical product profile, which is maybe common for all the refineries in the world. The LPG is only 3%, but you know the reach of this LPG. LPG is used as a cooking gas, and petrol and diesel are the commercially used fuel. The aviation turbine fuel is the fuel to the aircrafts. Naphtha, FO, LSH is used as fuel, and bitumen is again a very, very sought after product during a non-monsoon season for laying the roads. And the Mumbai Refinery of BPCL also produced lube oil-based feedstocks, which will help the lube strategic business unit of BPCL to market MAK brand of lube oils. The refinery is supported, governed, and having the following ISO standards: ISO 9000, ISO 14,000, ISO 50,000, 45,000, and 17,025. And all our labs are accredited to NABL, the National Accreditation Board for Testing and Calibration. So you can be well assured that any product that you buy in the market is certified by a lab which is having NABL certification. The entire oil industry is governed by the Oil Industry Safety Directorates. This is sitting at Delhi, which coordinates with the Ministry of Petroleum Gas and other technical institutes around the world to set standards for safety across the oil industries. Till now, the OSD has published more than 120 standards on various aspects of the refinery safety. So OSD is the Bible of the Indian petroleum refinery. Then we also have the American Petroleum Institute standard, which is normally called API standards, which develops and promotes safe, proven engineering practices. So all the refineries in the country today are following the OSD and API standards for all its facets of operations, including commissioning, including the layout of the various equipments and the design of various equipments. Now, I think this is a subject that will be of interest to all my friends who are listening to this program. Now, where do we want the help of chemists, or where do we have the requirement of the chemistry professionals to help us? I would like to tell one point very clearly here is that the gap between chemical engineering, chemical technology, and chemistry is narrowing down day by day. And in the future, I see in the next 5 years down the line that everything will become one major subject, which is predominantly governed by the fundamental concepts of chemistry that you have learned, also with certain engineering backgrounds that has been developed by the chemical engineering forefathers. I think these two are going to merge. This is what I feel, and this is likely to happen probably in the next 5 to 7 years. So where where we have requirement or where we seek your help is we require lot of work that needs to be done in catalysts and chemicals required for refinery processes. See, the catalysts are the basic workhorse of any refinery, any process industry, because catalysts are specifically designed for achieving a particular reaction in a particular way at a particular time without the catalyst undergoing a chemical change. This is what we have all learned as the catalyst. However, what happens in the normal operation is that the catalyst over a period of time will deteriorate because of arduous conditions that it is seeing in the units, and also by the formation of a particle called coke, which is depositing in the catalyst as a part of the process. So this brings the life of the catalyst down. So any help that is extended by you by way of good research in extending the life of the catalyst by giving the catalysts a better surface area, a deep surface area, tolerant to coke and poisons, will help the process industry as such, and particularly the petroleum refining. Also, the chemicals, we are handling more than 70-75 types of chemicals inside the refinery. These chemicals are used for water treatment, they are used for corrosion services, they are used for anti-foaming substances, they are used for even sometimes additive as per the BSI requirements. So there is enormous scope for Make in India. Let me reiterate the fact that enormous scopes exist in this second point for a Make in India concept. And if we are able to substitute very costly chemicals, for example, there is a chemical called dimethyl disulfide, which is called DMDS in the refinery parlance. This chemical is still getting imported. So if we are able to develop an indigenous technology to develop cheap DMDS, then it will be of good use to the refinery. I am leaving it as a food for thought for all my viewers here. Then characterization of feeds and products. Assuming that we give you a bottle of crude, how deep you can go to characterize this crude, find out what it is capable of and what sort of poisons it has. This information, like the visiting card, we require this information on a very fast basis. What I'm trying to say here is that a full crude assay will take about nearly 6 months to complete to get the full profile of the crude oil. But any effort from your side in enabling quicker techniques to characterize these feedstocks and the products that we generate will help the country at large. Then lab scale technology evaluation. This is another area which I would like to touch upon here. Normally what we find is that we produce lot of engineering and doctorate papers, but these papers are hardly converted into actual industry. What happens is that there is a stage from the paper, it has to go to the pilot plant. From the pilot plant, you have to scale up the pilot plant for commercial application. This cycle, we find that especially in India, where the conversion from paper to actual industrial design, there is a lot of time that is being spent on this. So there are number of grants that is now available by the government of India. So I request all of you to utilize all these grants and try to ensure that from the paper to the commercial processes, this time is reduced. In the European and American countries, I'm very sorry to say here that the time for this is nearly half, or even say 35 to 40% time they are able to commercialize. We have to go to that standard. Then the next point is the quality control laboratory, testing refinery streams and qualities, final product certification. needless to say, it is the bread and butter of any chemistry professional, but we require more quick testing, more testing which is having more repeatability and reproducibility, which will enable to certify products at a faster rate. The next point, water treatment system. It is one of my favorite areas. Wherever I am speaking, I am drawing the attention of all of you for spending a lot of time in water treatment. See, water is going to be the next oil. Let us be very clear. So water, like oil, is not going to last forever. And this fresh water, raw water that we see, it is going to, time is going to come very quickly that we will be fighting for even a bucket of water every day. So at that point of time, if India as a country needs to be, if we have to be in the forefront, that the only field that is going to help is this water treatment. How effectively we are able to reuse this product or reuse the water, how effectively or how quickly we are able to remove the contaminants from the wastewater and make it available as drinking water. I think this is going to be the order of the day. And for the industry, I am sure one day will come when the government will say, boss, you please stop all your raw water intake. Whatever, we will give you one batch of water. You please try to recirculate this water continuously and ensure that, you don't take raw water from the government. At this point of time, nobody can help except for the chemistry fundamental professionals who will be able to help us here. So I urge whoever is interested in water treatment, please let us know your thoughts on this. If you have got any ideas, BPCL will welcome, and let us see how we can work out. And also, I suggest that you may please also contact the the eminent professors at Cochin University who have a tie-up with Bharat Petroleum to ensure that good papers are encouraged and the industry academia relationship is further strengthened. Needless to say, effluent treatment system both in the domestic sector and the industrial sector needs extreme further treatment. I don't think we will be able to sustain the operations like this in the future. Chemical injection system, usage of additives, petrochemical formulations. Petrochemical, I will just spend some time in the next slide. These are also equally important. Now, another area which I would like to introduce here is that at Kochi, BPCL is going to, it is in the advanced stage of commissioning the propylene derivative petrochemical project. The unit is going to produce acrylic acid, oxo alcohol, and acrylates. And all these products are import substitute products, make in India products, which is going to save millions of rupees for the government of India as foreign exchange. So these products are now available. So how best you people can utilize these products for further downstream value-added products, you may please think about. And further to it, Kochi Refinery is going to have the polyols project, polypropylene glycol and monoethylene glycol. So this is also I am leaving for food for thought. Please try to find out what more can be done with these value-added products. And at Mumbai Refinery, we are going to replicate what is happening at Kochi at Refinery. So the future is not fuel. The future is going to be petrochemicals. So the refineries operating, say, 15 years, 20 years down the line, you will find those refineries producing more of petrochemicals than of fuels. So more effective conversion of the streams which are currently being used for producing petrol and diesel will likely to move towards petrochemicals. So this is the new mantra, and which is going to be a reality in probably a decade or two. Of course, this is a general slide which I wanted to assure all my viewers that all the refineries in the country, including BPCL group of refineries, are having the best safety and best fire protection systems. we have the complete refinery is mapped by hydrocarbon monitors, which we can detect any sort of small leaks anywhere in the refinery, and we can attack it and close it. And this slide is basically a self-explanatory slide. You can go through it at your leisure. If there is any doubts, you can contact me. So what are the challenges for the refineries in the future? The high volatility of the crude oil products, crude oil prices, I should say, sorry. The COVID has taught us to operate in a very different regime altogether, but the crude oil prices are fluctuating so much, and in the international market, we are hardly getting a stable price. So this is continuously affecting our margins. And as I told you, there is a reduction in demand in the growth of HSD and petrol, because first the EVs are coming in, and also, as I told you earlier, there are other fuels like hydrogen, which is coming in for automotive fuels. So all these are going to bring down the consumption of diesel and petrol lower in the country. So in the future, the streams that are currently going to diesel and petrol will be converted to petrochemicals. And also, we are having very stringent environmental norms now, and we will be able. The more that tighter the norms are, the more costlier the process will become. And refineries have got no choice but to follow the latest guidelines on the environment, which BPCL as a group is always in the forefront of ensuring that the refineries are operating within the parameters that is specified by the government. Operating cost is increasing because day by day the catalyst price, the chemical prices are going up. This is where I have sought your help also. Heavy fuels demand is coming down, and effluent treatment, availability of water, I have already talked about at length. So basically, this brings to the end of my slide, end of my talk. And I'm prepared to take a few questions if it comes. And before I conclude, I would like to acknowledge the following people: Dr. Madhu from CUSAT for being my mentor in chemical engineering throughout my career. Basically, I started from Kochi, then I moved to Bharat-Oman, Madhya Pradesh, then Mumbai Refinery. So he has been like a sort of a mentor to me in chemical engineering. Thank you, sir, Dr. Madhu. And to the organizers of MATCON for the invite, which I am very honored to accept. And to Satya, my colleague, for putting forward all these slides. Thank you very much. And I am prepared now to take some questions.
Okay. Thank you, Shri Chandrasekhar, for the very nice presentation, and also for keeping the time. Now the talk is open for discussion.
Hello, Dr. Chandrasekhar. That was a wonderful talk. I have a very simple question. Hello.
Yes, sir. Please go ahead.
Yeah. You are talking about desulfurization. I was just wondering what happens to this sulfur. How does it come out? Elemental sulfur or thiophene?
Sir, if I have understood your question correctly, you wanted me to elaborate on the desulfurization process.
Yeah.
Is it right, sir?
Yeah, that's right.
Yes, sir. Basically, I would like to draw your attention to the Bharat stage norms that is fixed by the government of India. See, before 15 years or so, the sulfur in diesel used to be as high as 2,500 ppm or even more than that. And today, the sulfur in the diesel is less than 10 ppm, which means the refineries are geared up to produce a diesel from 2,500 ppm sulfur to less than 10 ppm sulfur. This is achieved by the desulfurization of the diesel. Now, if you look at diesel per se in the petroleum crude assay, the sulfur has got a number of species. It can be a thiophene, it can be the normal sulfur, it can be the aromatic base sulfur. The sulfur group itself, I can speak for probably one session I can speak. But to answer your question, this sulfur is again dependent on the type of crude that we are processing. And the crudes are getting harder and harder, for which the sulfur molecules are also the complexity of the sulfur molecules are also increasing day by day. So it is now becoming a big challenge. So to remove the sulfur and make them convert the sulfur into H2S, that is the major challenge. And this catalyst has to convert probably any type of sulfur compound into H2S. That is the challenge here.
Okay. Thank you. Thank you very much.
If there is no more question, let us thank Shri Chandrasekhar for his very nice presentation on the petroleum refining process. Thank you, Chandrasekhar.
Thank you, Chairman. Thank you, sir. And sir, I will be logging out now because I have to go for another meeting, sir. Thank you very much.
Thank you, sir.
Thank you.
So we will contact you if there is any more questions. If there are some
Yeah. My email address and my phone numbers are with you. You are free to share this with the participants and ask them to contact me for any further clarifications, which I will be happy to provide. Okay.
Thank you so much.
Thank you very much. It has been a pleasure interacting with you. Thank you so much.
The next speaker is Dr. Rajesh Krishnan. Actually, he is an old student of this department. He had his PhD from the polymer chemistry division of this department under Dr. Sugunan. His wife is also an old student of this department. I am very happy to chair the session in which Rajesh Krishnan is speaking. Actually, he has his MSc from MG University, Kottayam, PhD from Cochin University, I have already mentioned. He had postdoctoral experience in Institute of Organic Chemistry, Warsaw, Poland, then University of Nebraska, then University of Buffalo. Then he worked as a research scientist in ANRIS Pharmaceuticals